Okay, guys, so today we are going to learn about rational functions. So on Wednesday or Thursday, depending on when you had class, you did a Desmos on this to kind of get an introduction and explore this. So now what we're going to do is actually graph rational functions. So a rational function, this is an example of a rational function, just means that you have x in the denominator. In algebra 2, we're always going to have 1 on top. That's your vertical stretch. So it'll always have a vertical stretch of 1. So if I plugged in -3 for for x, it'd be 1 over -3, 1 over -2, -1, because 1 divided by -1 is -1. And when you do 1 divided by -1/2, you actually get -2 there. And 1 divided by 0, we've learned before, this is called undefined. 1 divided by 1/2 is 2, just like we did up here. 1 divided by 1 is 1, 1/2, and 1/3. When you're doing this, the only ones you really have to focus on are these points. And you do have to realize that if it's undefined, it would never touch there. So you have -1, -1, -1, and you have 1, 1. And then -3, -1/3, -2, -1/2, and then 1/2 you go to 2. And again, you're going to get this really nice curve that never touches the x or y axis, and we're going to do the same thing on the other side. So you have 1/2, 2, and there, and connect. The big thing here, guys, is that you're going to have asymptotes, and you guys learned what an asymptote is the past couple of days. Your asymptotes are these lines that get increasingly near a curve but never actually touch. So you have two asymptotes. You're going to have x is equal to 0, which is this line, and you're going to have y is equal to 0. Which is this line. And you're going to get that because your parent function is always going to be in this form. F of x equals plus or minus 1 over x minus h plus k. And your x is equal to h. That's always going to be your vertical asymptote. And your k is always going to be your horizontal asymptote. And the plus or minus, this is positive, and I think about positive meaning it's going up over time. If it was negative, it being quadrants 2 and 4, it'd be going down. And we're going to do lots of examples like that. So for example, the number one thing you have to do here is you have to find your asymptotes. So here I have a vertical asymptote. Is there anything adding in the denominator with the x? No. So my vertical asymptote is x equals 0. So I go to x equals 0, and I'm going to do a vertical dotted line. I'm going to do the same thing with the horizontal. Is there anything being added? No, it's plus 0. So you know your horizontal asymptote is at 0 as well. So I go to y equals 0, and I would make a horizontal asymptote. From here, there's a trick to this. Do you guys see how you have this like new intersection? Do you guys see that? How the two asymptotes made an intersection? To graph these fast, if it's positive, you'd go up and right. Because this is negative, I'm going to go up and left and make a point. And then all you do is you curve it as close as you can to the asymptotes without touching. So if it's negative, you're going to go up 1, left 1, and you would go down 1, right 1. So I'm going to do the same thing. So down 1, right 1, make a point, and you do the same thing. You're going to curve it as close as you can without ever touching. The next part that we have to talk about is domain and range. Your domain is only affected by the vertical asymptote. So it's going to always go negative infinity to your vertical asymptote, union your vertical asymptote to infinity, meaning negative infinity to 0 because of this, and union 0 to infinity. And the same thing with this one. For your range, it would be negative infinity to your horizontal asymptote or your horizontal asymptote to infinity, which would be negative infinity to 0 or 0 to infinity. And I will continue this lesson on another video. Okay, guys?